Hey guys, welcome back to the QST YouTube channel. Today we will be solving the chapter 2 quizzes for the math periodic. Let's go. Written in terms of factors, n plus 2c3 is equal to n times n plus a times n plus 2 over b. Okay, now look, let's say we have nck. Okay, the rule will be n factorial over k factorial times n minus k factorial. Okay, so now let's start solving this question. So first of all, let's start with the numerator, which would be n plus 2 factorial over 3 factorial times n plus 2 minus 3 factorial. All of it factorial. And then we're gonna simplify. So that would be equal to n plus 2 factorial over 3 factorial times n minus 1 factorial. And then we're gonna need to figure out a way to cancel out n minus 1 since it's not in the denominator in the question. So we know that n, the factorial, let's say 3 factorial is equal to 3 times 2 times 1 factorial. Like 3 times 2 times 1, sorry. And then let's try and simplify. So n plus 2 times n plus 1 times n times n minus 1 factorial. Let's say we have 4 factorial, okay? It's equal to 4 times 3 times 2 factorial, for example, right? Because 4 factorial would be 4 times 3 times 2 times 1, which is 2 factorial. So it would be n minus 1 factorial over 3 factorial times n minus 1 factorial. We cancel out n minus 1 factorial up and down. Now that would leave us with n plus 2 times n plus 1 times n over 3 factorial, which is 3 times 2 times 1, which is 6. So here they want a, which is 1, and b, which is the denominator, which is 6. Number 2. Written in terms of factors, n plus 1 c3 is equal to. Again, we're gonna use the same rule. So we're gonna do n plus 1 factorial over 3 factorial times n plus 1 minus 3 factorial, which is equal to, like after simplifying, n plus 1 factorial over 3 factorial times n minus 2 factorial and then we're gonna do the same thing like the first question. So n plus 1 times n times n minus 1 times n minus 2 factorial. You stop like at the part where we reach the denominator. Like here n minus 2 factorial, we're gonna stop at n minus 2. over 6 times n minus 2 factorial minus 2 factorial. You cancel it up and down, and that would leave us with n plus 1 times n minus 1 over 6, like here. And then we're gonna do the same thing for part B. So n plus 3 factorial over n minus 1 factorial times n plus 3, we're gonna put it separately, minus n minus 1 all of this factorial, which after simplifying will give us n plus 3 factorial over n minus n cancels, and 3 minus negative 1, which will give us 4 factorial. So 4 factorial times n minus 1 factorial. Then again we're gonna do the same thing. So n plus 3 factorial, n plus 3 times n plus 2 times n plus 1 times n times n minus 1 factorial over 4 factorial, which is 24 over n minus 1 factorial. You cancel n minus 1 factorial up and down, and that will give us n plus 3 times n plus 2 times n plus 1 times n over 24, which is here what we're looking for. Number 3. What whole number is equal to 12C3? This is relatively easy. Like, we only need the calculator. So you're gonna do 12 shift divide 3. So to get NCR, you're gonna do shift, which is SH, like what I'll do, divide. And that will give you the 12C3. So 12C3 will give us 220. Number 4. Why is it loading like this? Question, we're also gonna need to use the factorial. So to get the factorial sign, I completely forgot how to get it, but you'll see it as like x factorial. I remember it was like shift something. I don't have my calculator near me, but you're gonna do shift something to get the factorial sign. So you're gonna do 18 factorial just give me a sec. 18 factorial over 4 factorial times 15 factorial. Make sure to put the times in the, like in between the 4 factorial and the 15 factorial, because it won't work if you don't put the times in the exam. And that will give us 204. Number 5. A simplified expression for 1 over 3 times n minus 1 factorial minus 2 over n plus 1 factorial. First of all, we need to know that n plus 1 factorial, to make it easier for us, is equal to n plus 1 times n times n minus 1 factorial. Okay, so now let's start. So wait, let me just grab the question, add to new page. Okay, so first, oh my days. First, let's write the question. 1 over 3 n minus 1 factorial. Minus 1 factorial minus 2 over n plus 1 factorial, which is, as we said, n plus 1 over times m times n minus 1 factorial. You'll see why this is important later. And now we need to make it common denominator, right? So how do we, the common denominator would be 3 times basically n plus 1 times n times n minus 1 factorial. This will be the common denominator. So how do we go from this to this? We're gonna multiply by n plus 1 times n in the numerator and the denominator. So n plus 1 times n over 3 times n plus 1 times n times n minus 1 factorial for the second fraction. All we need to do is multiply by 3, right? Because we do not have 3 in the denominator for this fraction. So we're gonna multiply by 3 up and down. So minus 6 over n plus 1 times n plus 1 times n times n minus 1 factorial. Okay, and now we're gonna distribute here and we're gonna minus 6, so that will lead to n squared minus n, n squared plus n minus 6 over 3 with whatever we got, 3 n plus 1 n and n minus 1 times n minus 1 factorial. Again, as we said before, all of this is n plus 1 factorial, so we can just simplify it. N squared plus n minus 6 is equal to 3 times n plus 1 factorial. So that will be it for 2.1. The next questions you're gonna see soon are for like 2.2. For this quiz, okay, what's included is question 1 to 8, question 10 to 13. Let me just make sure. 10 to 12, sorry. 10 to 12 and 15 to 19. Okay, let's get started. Okay guys, so for this question, it's probably the toughest question in the entire material, probably. So we're gonna have to take 1 plus 2x as a and negative 3x squared as b. And then we're gonna expand normally. So let's start with Pascal's triangle to know the coefficients. 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, which will be the coefficient if the power is 4. So let's start. 4, C, 0. Actually, not yet. First, let's start with 1 plus 2x to the 4 times, plus 4 times 1 plus 2x to the cube times negative 3x squared plus 6 times 1 plus 2x, all of that squared, times negative 3x squared, all of that squared, plus 4 times 1 plus 2x times negative 3x squared, all of that cubed, plus negative 3x squared, all of that to the 8. First of all, let's start eliminating where we would not get, till x to the 3. So first of all, let's eliminate negative 3x squared to the power of 4. Okay. Let's also eliminate this, because it will result in more than x cubed, and this as well. So now we only have these two left. Add to new page. So now let's remove this, bring this up. Then I'm gonna add the form of the question that they want, which is this, to current page. Okay, so now we're gonna have to simplify this. So again, we're gonna use Pascal's triangle for this. 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, first let's start with 1 to the 4 plus 4 times 1 cubed times 2x, all of that to the power of 1, which is 2x, plus 6 times what's it called? My days. 6 times 1 squared times all of 2x squared plus 4 times 1 times 2x, all of it cubed, and then 2x to the 4, it doesn't matter because it will be more than x to the 3. So 1 plus 8x plus 24x squared plus 32x cubed. Then let's put that in the next page. We're gonna erase 1 plus 4, 1 plus 8x plus 24x squared plus 32x cubed. Okay, so now for 4 times, okay, just give me a sec. So now we need to simplify this. First, let's multiply negative 3x squared with 4, which would give us negative 12x squared. And then we're gonna do Pascal's triangle again. So 1 cubed, right? 1 cubed plus 3 times 1 squared times 2x plus 6 times 6 times 1 times what? 1 cube. Oh wait, no, my bad. So 1 3, and then this is 3 as well. So 3 times 1 times 2x, all of that cubed, plus 2x to the 4, which we ignore. So that will give us, let's simplify, 1 plus 6x plus 3 times 8, which is 24x cubed. Okay, and then negative 12x squared. Let's distribute. So negative 12x squared minus 72x cubed minus whatever x to the 5, which we'll ignore because it's more than x cubed. So negative 12x squared minus 72x cubed minus 12x squared minus 72x cubed. This will give us 1 plus 8x plus 12x squared minus 40x cubed, which is what they're asking for here. Finally finished this question. It took me too long to understand and explain. Number 2. In expanded form, a plus b to the 4 is equal to, this one we used Pascal's triangle, 1 1 2 1 1 3 3 1 1 4 6 4 1. So the coefficient here is 1, and then each one we move like next one, the power of a will decrease while the power of b will increase. So here b is 0, like the power of b is 0, and here the power of b is 1, then here b is squared, and then it will increase while the power of a decreases. So 1 4 6 4 1, and the power, again as I said, as we keep moving, the power of A will decrease while the power of B will increase. Number 3. In expanded form, 2 minus x squared to the 5 is equal to. So let's start. So 5c0 negative, oh wait, sorry, 2 to the 5 times negative x squared to the 0 plus 5c1 times 2 to the 4. By the way, the rule is like nck, let's say for like expansion, like here, n will be the power, k will be like a counter from 0 till the power, then a to the n minus k, then b to the k, then negative x squared to the 1 plus 5c2, they want here till x is 10, which means 5c5. So again, 5c2 times 2 to the 3 and negative x squared plus 5c3, wait, actually this is cubed, oh my goodness, it's squared actually because b to the k, then 5c3 2 squared, and then negative x squared, all of that cubed, plus 5c4 2 to the 1, just 2 times negative x squared to the 4 plus 5c5, okay, 2 to the 0 and negative x squared to the 5. Now let's start eliminating what they don't want. So here we're gonna start from 0, like from right to left we're gonna start from 0, because here, like when 32 is here, there is no x, which means the power of x is 0, which means 5c0. So we're gonna start from 5c0 till the end from right to left. So 5c0, which is 1 times 32, which is, and then this will be cancelled. So we got the first one. Then they also want 5c1, which is 5c1 is 5. Let me just 5 times 2 to the 4, which is 16, and then negative x squared is just x squared, which will give us negative 80x squared, which we already have. They don't want when k is 2 or when k is 3. So k is 2, k is 3 out, and again when k is 5 they don't want. So they just want 5c4. 5c4 is equal to 5. So 5 times 2, which is 10, times negative x squared to the 4, which is 10x to the 8. Number 4. Which is the coefficient of the x to the 5 term in the expansion? So here they want x to the 5 term. So 7 ck 2x to the 7 minus k negative 1 over 4 to the k. Then 7 minus k is 5. It's 5. K is 2. So 7c2 2x to the 5 times negative 1 over 4 squared. So again, 7c2 times 2 to the 5 times negative 1 over 4 squared. All of that squared, which will give us 42. Number 5. What is the coefficient of the term in x squared, x to the 10 in the expansion of this? Okay, now for this one it's slightly trickier. There is no problem about it. 5ck x to the 4 times 5 minus k times negative 3 to the k times x to the negative k. This is because we took x from the denominator up. So, and then to make it, to simplify, first of all we're gonna have to do power. Here we have the power of power, which means we're gonna multiply. So 20 minus k minus k, because we're combining like terms, which is x and x in this case. So 20k minus 20 minus 4k minus k is equal to 10. 20 minus 5k is 10. K is 2. So now we substitute. 5c2 x to the 12 negative 3 squared, then x to the negative 2. So 5c2 times 9, which is 90. Number 6. What whole number is equal to this? Just shift log on the calculator to get the sigma, and then put x is 1 and on top is 6, and then you distribute the 2i, so you get 2x squared plus 2x, which will give you 224. Number 7. What is the coefficient of the x to the 5 term? Again, 7ck x to the 7 minus k negative 2 to the k, then 7 minus k is 5, k is 2, then we're gonna substitute k by 2, so 7c2 x to the 5 and negative 2 squared. You substitute k by 2, so 7c2 times 4 basically. 7c2 times 4, which is 84, which is what the answer is. Number 8. Wait. Of course it freezes. Of course it freezes. This one is kind of hard, but it's not. It looks hard, but it's not. So negative 3 over 4 is C3 is equal to negative 77 over K. What is the value of K? You can't do this on the calculator, but there is a simple way of doing it. Since the number up is rational, like it's either a fraction or negative, we're gonna do this. Negative 3 over 4 over 3 factorial. And then we're gonna go back like 3 times. Like this will be the first value. Second value would be negative 3 over 4 minus 1. And then it would be negative 3 over 4 minus 2. Again, this is 6. So on the calculator, you put negative 3 over 4 times negative 3 over 4 minus 1 times negative 3 over 4 minus 2, all of that over 6, which will give us negative 77 over 128. Number 9. This question is not included as I said. So number 10. For this question you can do on the calculator shift log x is 1 till 20, so 2x squared minus 3x plus 2, which will give us 5150. Number 11. What is the coefficient of 1 over x cubed term? So the 1 over x cubed, okay, this is equal to x to the negative 3. Then first of all, let's like write the rule, and we're gonna split the numbers and the variance. So 7ck x to the 7 minus k (3 to the negative 7 plus k), because you took it from the denominator up, so negative 7 plus k, times 3 to the k times x to the power of negative k. Now you do 7 minus 2k is negative 3. K, you get k is 5. 7c5 x squared, because you substitute k by 5, 3 to the power of negative 2 times 3 to the 5, and then x to the negative 5. The x's we don't care about because they gave us the variable part. So you do 3 power 5 times 3 power 2. This is equal to 3 power 3 times 7c5. So 3 power 3 is 27. So 27 times 7c5, which is 567. 67. Oh my god, we should cut that out. What is the constant term in the expansion? So 6ck 2x squared, all of that to the power of 6 minus k, plus x to the power of negative k, because we took it from the denominator up. And then again we do the like terms, so 6ck, and then we're gonna do 12 minus 2k minus k, which is 12 minus 3k is equal to 0 because the constant term, the power of x has to be 0. So k is 4. So now that we know k is 4, 6c4 2x to the power of 2, wait no, 2x to the power of, what's it called? I'll just do it normally. 2x squared to the power of 2 times, it's not plus here, sorry, times x to the negative 4. Okay, so you distribute the power here, so it becomes 4 times x to the 4 times x to the negative 4 times 6c4. Then these two are gonna get cancelled out, so you do 6c4 times 4. 6c4 times 4, which will give us 60. 13 and 14, if I'm not mistaken, are not included. Wait, 13 is not included, 14 is not included. Then let's keep going. The binomial expansion used to approximate the value of 1.02 to the 6th. The first term is 1 and the fourth term is 0.000088. What is the integer? So 6ck. First of all, we're gonna have to split it, so 1 plus 0.02 to the 6. So 1 plus 0.02 to the 6. And then they want the fourth term. So 1 to the k, and then 0.02, 6 minus k, and then 0.02 to the k. Now to figure out what k is, you can do 0.02 to the power of x is equal to 0.12345000008. So k is 3. So 6c3, you continue, this doesn't matter because it's 1, and then they already gave us this, so you just do 6c3. 6c3, which is 20. We have 15 out of the way now. 16. Using the sigma notation, 1 plus 3 plus 5 to 101. Okay. So remember last year when we took, I don't want to explain it again. They want to figure out the sigma notation. So let's say we have the first term, which is t is 1. So 2 times 1, okay, plus, let's say box, will give us, okay, sorry, like 0, 0, sorry, will give us 1 because we start from t is 0. So, and they give us 2t plus box will equal 2. So 2 times 0 plus what will give us 1. So this will be 1. Okay, then how do we get this 50? You may ask. Look, so here they basically want t when the answer of this 2 box plus 1 is equal to 101. Or 2x, you can make it anything. So 2 box is equal to 100. The box is 50. Box is 50. It's just like algebra, basically. But just to make it more complicated, they add sigma and these numbers. Wait. From 1 to 5, sigma 1 to 5, I squared will be equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. This is because I goes from 1 to 5, and then we'll keep squaring it like until 5, which is when the pattern ends. Number 18, there is a simple way to solve it on the calculator actually. So you're gonna do radical, put this on the calculator, radical 3 plus radical 5 to the 4 minus, again you do the same thing, radical 3 minus radical 5, all of that to the 4. This will give you, look on the calculator, it will give you a decimal, so you square the answer. So for this one you put it on the calculator, calc, and then you answer squared. Then once you get that answer, you square root the answer, and it will get you 64 radical 50. Number 19, which is the last and final question. It's not coming, by the way. If I'm not mistaken, it's not coming. Right. Solve part A just in case. But part B, I don't think it's coming. So, we're gonna do... Is it coming? Is it? I think it is. Part A is gonna be coming. Like I'm just gonna solve part A, and part B I don't think we learned it. So for part A, they want the x cubed term. So 1 over 4 ck 1 to the 1 over 4 minus k, we just ignore it, just 4x to the k. K is 3 immediately, since they want the coefficient of it to be 3. Then we're gonna do the fraction way, since 1 over 4 is rational, not natural. So we're gonna do 1 over 4 times 1 over 4 minus 1 minus 1 times 1 over 4 minus 2 over 3 factorial, all of that times 4 cubed. So you go to the calculator, fraction, another fraction, 1 over 4 times 1 over 4 minus 1 times 1 over 4 minus 2 over 3 factorial, which is 6, times 64, which will give us 7 over 2. Thank you guys so much for watching this video. We hope you guys the best of luck in your periodics, finals, whatever you're watching this before. And goodbye.